Well, now we are further continuing with the communication system, and our context of discussion will be amplitude modulation. So we have to go through the amplitude modulation. As it is clear from the earlier discussion, modulation means the mixing of two signals. So basically the audio signals converted to electrical signals by microphone, and then they are superimposed on the carrier signal which are generated by Hertz oscillator. So that is what is the meaning of modulation. And when we use this term amplitude modulation, it means we are trying to set up the amplitude, that is the displacement of the wave. So amplitude modulation means first modulation is carried out and then we have to maintain the amplitude of that modulated wave. Then we have to go through with the amplitude modulation wave, and we have to give the main features of the amplitude modulation. So now we come to the main concept, that is amplitude modulation. When we speak, as I have explained earlier, that is modulation is the mixing of two signals, and amplitude modulation means maintaining the amplitude of those mixed signals. So it is a process in which the amplitude of the high frequency carrier wave changes in accordance with the instantaneous value of modulating signal. Here, a voltage proportional to amplitude of the modulating signal gets added to the carrier amplitude. So carrier means radio wave and it has got an amplitude. So what exactly we have to do? We are using here a term that is modulation, and then we are also using the carrier amplitude. Carrier means radio wave and amplitude means the amplitude of the radio waves. So voltage proportional to the amplitude of the modulating signal. So when we say amplitude of the modulating signal, it means the mixed signal has some amplitude and voltage will be directly proportional to that amplitude of the modulating signal, and it gets added to the carrier amplitude. Now we have to go through the waveform of the amplitude modulated voltage. Now we are involving the electrical phenomena in this whole concept. So according to the figure, like figure A, we will see on the right side, figure A is showing unmodulated carrier voltage. That is, amplitude is fixed in this figure. So it is one of the signal in which amplitude is not changing. So B figure is showing a sinusoidal modulating voltage. It means the signal is in the form of AC curve, that is in the form of sine curve. And the general equation of the sine curve will be y is equal to a sine omega t, where omega is the angular frequency. And we find the C figure, that is amplitude modulated voltage, that is the A and B signals are mixed together, and that is called amplitude modulated voltage. So now we come to the main form, that is the waveform of the amplitude voltage. Figure A shows an unmodulated carrier voltage. Wherever we are using carrier, we are referring to radio frequencies. Unmodulated means when the mixing is not done. Now figure B, it shows a sinusoidal modulating voltage. So modulating means the mixing of signals and in the form of sine curve, and sinusoidal modulating voltage means that the signal will be in the form of audio signal. And figure C, that shows amplitude modulated voltage, the mixing of the first two signals. Clearly, the amplitude of the carrier wave changes in accordance with the modulating wave. So carrier wave is radio wave and its amplitude will change when the modulating wave will have the variation in its amplitude. During the positive half cycle, now we are basically carrying out the concept of rectification here, and in rectification we find the sinusoidal signal is used in such a way that for positive half cycle, which is existing for 1/100 second, there will be some work done, and for negative half cycle at that time there will be no work done. But then for next 1/100 second, again there will be work done, and for next 1/100 second there will be no work done. This concept is working in the rectification. So during the positive half cycle of the modulating signal, the amplitude of the carrier wave increases. Now during the negative half cycle, the upper portion, that is the crest portion, that is called the positive half cycle, and the trough portion is called the negative half cycle. So during the negative half cycle of the modulating signal, that is the mixed signal. Mixed signal means audio signal plus radio signal or the carrier signal. The amplitude of the carrier wave decreases. Thus, the top and bottom envelopes of the modulated wave are just the replica of the modulating signal. Now, there are certain important features of the amplitude modulated wave. So, what are the important features? As I have explained earlier, that modulated means the mixed wave in which one of the component is audio wave in the form of electrical waves or electrical oscillations, and other component is a carrier wave. So when they mix together, that is called a modulated wave. And when we speak amplitude modulated wave, it means we have to check up the amplitude or the displacement of the modulated wave. So there are certain important features of the amplitude modulated wave. The first important thing is amplitude of the carrier wave changes according to the modulating signal. So amplitude of carrier wave depends upon the modulating signal, and carrier wave is related to radio frequency or the radio wave. Radio waves are electromagnetic waves, and effect of electric and magnetic field are neglected in this situation. Second one is amplitude of the carrier wave changes at the frequency FM of the modulating signal. So FM stands for that is frequency of the modulating signal. So when we use the signal, we are referring to simply waves, nothing more than that. So amplitude of the carrier wave means we are referring to the displacement, maximum displacement of the radio wave or radio frequency. It changes at the frequency FM of a modulating signal. Number 3 is frequency of the amplitude modulated wave is equal to unmodulated carrier frequency, and that is FC. So FC means that is frequency of the carrier wave, and FM is the frequency of the modulated wave.